So thank you for the introduction. So actually, it's a bit long time because before the COVID I talk a lot, but after that I almost forgot how to do the keynote, and I have drunk too much yesterday, so I have no chance to dry run. So I don't know how much time is consumed. Maybe too short, too long. I don't know. But anyway, let's go. So today I talk about the vehicle intelligence 2.0. So this kind of new angles. But surprisingly, most of the content, my talk is overlapped with Mizuyama-san, surprisingly. So let's start with the vehicle system architecture. Mizuyama-san pointed the logical architecture and the physical architecture are different. Because we are the chip company, Renesas, and the tier one is making a box. So they care about the physical box, physical chips. So if the customer consolidate the two things into one, so our business volume is decreased. So if you see the vehicle architecture, they're seriously concerned about the physical thing, but not so many people consider about what is the logical architectures. But today's talk is most like the vehicle system architecture, the migration stuff. So in the past, so AGL spent a lot of effort to catch up the smartphone experience because the Google and the Apple educate people a lot to the pinch swipe type of the intuitive HMI operations, and many people without any conscious using a pinch to expand the maps. This is people already educated, and that kind of feature is already in place, I think. So maybe there's a human-centric operation, HMI, and cloud connectivity. Oh, I need a glass here. So it's including the layout and icon-based, and also including voice operation. So AGL also supports this kind of stuff already. And cloud connectivity. So of course the vehicle is not always connected to the cloud, but somehow connected and reflecting the vehicle side, cloud side data. So that kind of things already in place. And currently we are consolidating just for the example, so the IVI ECU and ADAS ECU work together to make one screen, the one cluster, including the maps and also the ADAS alert information in place to help people to understand how to drive. So it still relies on the human intelligence to how to drive a car. Of course, it's much better than nothing, but this is what I call the vehicle intelligence 1.0. Because maybe a long time ago, maybe 45 years ago, there was no microcontroller used in the vehicles, like the Ford T or something. There are no microcontrollers there. And they start using a microcontroller for the ABS and the fuel injection system at first. So if you start using the microprocessor in the vehicles, it has intelligence. And that intelligence was encapsulated into one ECU box. That means one ECU has some data collection, some sensors, actuators, and some algorithm inside. So the ABS and, for example, the fuel injection no need to coordinate together because this is completely different systems. But it's getting different story like ABS and EPS. EPS, electronic power steerings, and lock brake system need to communicate somehow to achieve the better things. So I want to say that this traditional intelligence is vehicle intelligence 1.0. So independent to each dedicated to the ECU box. And typically each box is developed a different tier one. So it's very easy, not easy to coordinate together because OEM don't have a code and the OEM don't access inside the ECU box. So they only care only the traffic data running on the CAN traffics. So this is the current shape. And now the car company, automakers, needs more than smartphone experience. We already achieved the smartphone things, and many new challenges are happening. One thing is battery use optimization. So battery use, because the EV and even a HEV car, the battery life is very critical. So each car company is trying to utilize, extend the use of the battery life. And the second one is advanced safety and advanced security. So some OEMs start saying that it's a skill-oriented assistance. That means, of course, the driver's skill differs. Someone just start driving, someone is getting senior. So capturing how they smoothly drive the car, and if they are smart enough, then the minimum is a lot. but it's maybe this driver is kind of newbies, so they proactively give the same guidance. So please slow down, please take care of things. That kind of thing is responsible to the driver side. So this kind of the skill-oriented, and the cloud-assisted means they rely on some of the weather condition, the load condition, so they depend on such kind of external condition, they slightly adjust how to coordinate, for example, ABS, this kind of thing. So this kind of advanced safety and the batteries optimization is getting very, very serious for the automakers, especially the BEV age. So this is examples. This is quoted from the Toyota, the new president Sato-san. They propose the 3 major pillars that they including in Japanese the chinoka, the kuruma no koi o kiku. That means the intelligence listening more to what car have to say. So this is one important pillar in the Toyota. And this is the BYD. The BYD is a bit kind of small that I try to read that. So they say intelligence, the domain controller BYD OS. Operating system facilitate highly intelligent driving. Hardware and software work together to enable continuous evolution the entire vehicle. So this is the big intelligence 2.0 examples. So I want to say the intelligence 2.0 need each ECU communicate each others and dynamically. So because as I introduced, currently, for example, cluster ECU is just referring the data and display it, but just no actual coordination happening in between the ECU box. But if you achieve the advanced intelligence, so because as I introduced, the ADAS ECU and the battery BMS, battery management ECU, need to coordinate to make some operations. This is kind of brand new, the entire vehicle intelligence systems. So now some central box should have some controllability, the brain inside. It may include the logical model or AI algorithm running here to coordinate each box, each issue box the data. So this is kind of new. And here's some examples. So I quoted this 3 stuff one from Toyota. And almost exact same thing is proposed. And the second is the Honda. Honda is included picture. It's easy. So in EV car, especially HEV car, if you set the route to the target, and if you have some going to some mountains, so if you drive down the slopes, so car can charge by that. So if car understands that thing, so you can consume the correct auto battery before the top of the slopes, and then down slope you can charge. So this is a kind of route respective the battery use management. The same thing also included by the Nissan. So this is surprisingly the Toyota, Nissan, Honda not so much emphasize this kind of intelligence yet, but I think that each car company is so serious about how to extend the driving range from the EVs. So they included this kind of new scheme to use this kind of the vehicle intelligence 2.0 kind of things. So now I want to say that all 3 stuff is needed, the IVI, BMS, and the live traffic information coming from the external clouds information need to coordinate to decide how to use the batteries. So this is kind of new. And this is actually happening, as showed in examples. Okay, my question is how we can make the vehicle system comply with this kind of intelligence 2.0. So initially, so each issue coming from different tier 1, different software provider need to communicate to each other. So they need to have some common languages. So this is the hierarchical taxonomy, that kind of data set. This is how to, I'm not talking about API. This is just a dictionary. So how to specify functions. So this is the kind of common industries need to share this kind of stuff. And also the current CAN network is just connecting in a loop. So each ECU can send the data randomly, and each ECU can pick them randomly, but there are no coordinator inside. So if you make some intelligence, some sort of the master domain controller, so see right-hand side, the violet box. So this guy need to know the discovery, the node registration, and the packet routing, the filterings, and access control kind of thing done by this centralized node. So this is a function, logical things. So any issue box can work as that use case, but it's at least some kind of coordinator. You can simply imagine the left-hand side IEEE 3094, and the right-hand the USB. USB has a clear host. Most network is the same thing. Most network is a dynamically set host, but it's very complicated. So if you set some specific role to control this kind of coordination, it's getting easier. That's why people start saying the centralized compute and the gateway. That's a major role of the new functions. And as Mizuya-san pointed, so the physical layout and the logical layout are different things. And to realize the freedom of the freely allocate the physical location, we definitely need to have some abstraction using the hypervisor. So hypervisor technologies are very key because we are talking about many OEMs, and we've learned that each OEMs has different physical layout. That's fine, because it's up to each OEM's some design policy and relationship with tier one, but logically, they need to have the freedom to relocate any features as they like. So the hypervisor is the key. And one engineering unique point is we are supporting the browser, so Chromium browser. You know, Chromium is a Google-based browser functions, and now the Microsoft started using that. So this is a kind of industry standard. And if you download the AGL UCB, it's integrated, already pre-integrated Chromium browser. Chromium browser is a huge asset, much more than the Linux kernels. If you simply download the Chromium code and integrate by yourself, it's big work. But UCB already includes that. And also we will start supporting the cloud connection. So as also Mizuya-san pointed, the newly named the SDB EG is working for the close connection. The AWS team guy is leading this activity, which is Jerry, and to support the pre-integrated cloud connectivity. Of course, it's not only for the AWS, but some sort of the cloud connectivity is already carried in a UCB. So this is a unique advantage to AGLs. Okay. So lastly, my question is how AGL can contribute to this kind of new intelligence 2.0 stuff. So as you've seen, now, because when we started AGL, maybe 13 years ago, maybe? 13, 14 years ago. So that was only our competitor was Genevieve at that time. And we are somehow coordinated together, but somehow competing each other. But now, too many, Zophie, SDB, ABSCC, many things, many similar organization is starting. So how, maybe you are a bit confused which organization to join, and they're chasing almost similar goals. So for me, they all, of course, the flavor of the activity are different, as Dan pointed, and Mizuya also pointed. The AGL is come with a code, so we come with a reality. But some organizations just talking about specifications, some organizations make the marketing relationship, but that's fine. But anyway, so all of them are chasing mostly for the two things. One, the software defined, another one is the cloud native. But these two things is, of course, important. But this is actually, I want to say, the seed technology, not the solution. So to use this kind of scheme, so you need to make a new value by make a new intelligence. So that's my point today. And this is examples. So that is the CES EPAM's demonstration using our hardware. So integrating the many functions, the cluster and the gateway and the Telltale and the many other stuff. Android AOS is also running as a guest OS. So this kind of the integration is all done, but maybe more interesting space, more like the vehicle stability control kind of thing, because it's still essence of a car, because a car is not a smartphone, so you still need to drive safely and drive faster and drive smartly, because that means the EV car need to charge, but the charge location is limited. So maybe because the charge location is size is different, if you are driving a big car and the small car occupies such space, that is not efficient. So small car used to guide to the small location, the big car to reserve the spot. So that kind of some industry level, the company levels optimization of the traffic is needed. So to do that, so I think that we want to. I want to utilize the AGL space to do such research. So my consideration, the vehicle intelligence 1.0 is already achieved by the software, also with the hardware logics, and running inside each ECU box. It's already happening. And OEM strives to improve the energy efficiency and the stressless driver passenger experience. And to achieve such challenging goals, vehicle intelligence 2.0 may be needed, and that consolidate the data from multiple issues. That's the point. And in the past, the AGL has contributed a lot of things, like the product readiness, the software framework, and Virtual-based virtualization and browser integration. It's already achieved quite a lot of things by the AGL. It's already part of the UCB code. And other organization, it also starts making some new stuff. That I want to say the seed technology. And maybe the AGL want to more focus on the advanced research, the reference implementation for the vehicle intelligence 2.0, because if you start seriously thinking of how to coordinate, many new things happen. How to synchronize the timestamp each different issue box, how to validate the data from each box. So this kind of new problem you may realize, and we need to find a way to how to improve that kind of thing. Maybe you can make some standard for that. And importantly, this exactly the right picture is the same as the Mizama-san pictures. We don't need to compete similar organization because we can use our own asset as well as their asset if they are. And we are more focused on how to coordinate, how to combine to make real systems. So I think the AGL is the perfect place to do this kind of research and also the experimental implementation to find a more better solution for the vehicles. So let's work together. Thank you.